Welcome to ClickMyProject.com. Now we're going to discuss about the project Polarimetric SAR image classification based on ensemble dual branch CNN and superpixel. Now we're going to discuss about the abstract of the process. In this process, a SAR image registration method is proposed, which is based on the combination of the three algorithms named as the SLIC, RANSAC and CNN algorithm. In this proposed algorithm, the multiscale representation of the SAR image is generated by nonlinear diffusion. Then the SLIC superpixel region transmission is used to detect the changes in the pixel intensity and then the region were splitted. To reduce the influence of multi-capture speckle noises, the ratio of exponential weighted average operator is used to compute the gradient information in the construction of the nonlinear diffusion space. Then the features will be extracted by means of the RANSAC and CNN model. Finally, the classification results shows the type of the land. For example, it is an urban area. In the sense, it will classify the model and then it will shows the result as an identified as urban area. Finally, the performance of the parameters will be evaluated by means of the accuracy, sensitivity and specificity. Mostly we concentrate on the accuracy to improve the performance of the calculations. In case of accuracy is high, the classification performance is high. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the modules such as input image, pre-processing, feature extraction, classification, identification and finally performance estimation. By these modules only we can do the process. At first, the input image is taken from the dataset, that is the SAR image dataset. After the selection of the image from the dataset, the corresponding pre-processing will be carried out. In this pre-processing steps, we have two kinds of pre-processing. One is the image resize, then the second one is the noise filtering. The resize is carried out to resize the image in the size of 256 cross 256, which means the number of row will be the 256, number of column will be the 256. After doing this one, the filtering is applied to remove the noisy pixels from the image. After doing these two things in the pre-processing, we just move to the feature extraction. So in this feature extraction, we have an options of RANSAC, CNN and SLIC. So we are going to use these three techniques to extract the matching point as well as the statistical features, then the textural features from the image. After extracting all these three features from the image, we just do the classification by means of the machine learning based on the distance matrices. After doing the classification, it will identify the which kind of land type is there. In case of land type 1, 2, 3, whatever it is, it will classify and then shows the results in the message box. After doing the classification, in this identification part, it will shows the identified results. Finally, the performance will be evaluated by means of the three parameters named as the accuracy, sensitivity and specificity. By using the accuracy, sensitivity and specificity, we can justify our process is efficient. Now we are going to discuss about the running procedure of the project. At first, open the Matlab 2019b and then change the current directory. If you want to execute the process, just right click in the main_GUI.m and click the option run. After clicking the button option run, you can see the user interface. In that user interface, you can see the several push buttons in the right side for the controlling actions and then the several axes and table in the left side for the display purpose. First of all, click the button input image. After clicking the button input image, the dataset will be open. In that dataset, you have to select any one image from the dataset. After the selection of the image from the dataset, the corresponding image will be shown in the axis 1 with the title of input image. After the selection of input image, we just move to the second stage of the project, that is the pre-processing. Here the resize is carried out to reduce the dimension of the image. In this pre-processing, we have two types of resize options will be there. One is the upscaling, then another one is the downscaling. After doing the pre-processing, the feature extraction is carried out. In this feature extraction, we already discussed in the flow diagram. There are the three features will be extracted from the image. Those features are shown here. The features or values are tabulated in this table, and then the feature images are shown here. The corresponding shift, SLIC and CNN values are shown here. After doing the feature extraction, we just move to the classification step. In this classification step, it will recognize the which kind of land type is there. In case if it is an land or sea, so forest area, hill, whatever it is, it will recognize and display the types of the land. So here the input we have given as an by the user is the land region, hence it is recognized and then displayed here. After doing the classification, the performance will be evaluated after clicking the button performance. In this performance, we have three kinds of performance parameters will be there. One is accuracy, then the second one is the sensitivity, and the third one is the specificity. By means of the accuracy, we can justify our processes efficient when it is above the 95%. Thanks for watching this video.